So here it is mentioned that we have a ball which is initially inside an aircraft and it is thrown out of an aircraft. Then the ball starts to fall towards the ground. The question is, which of the following shows the correct free body diagram showing the forces acting on the ball when the terminal velocity is reached? So let us revise the concept of terminal velocity. So terminal velocity is a velocity which after some time becomes a constant. Let me repeat. Imagine if the ball is falling towards the ground. Its speed will continuously increase until a time when the velocity becomes constant, and that is called the terminal velocity. Now, once that happens, since the velocity is constant, we can say acceleration is equal to zero. Hence, if I now use the Newton's second law, F net is equal to m into a, since the value of acceleration is zero, we can say that the net force is also zero. So overall, whatever forces are acting on the ball, the end result, the resultant of all the forces should be zero. Now, if we look at the options A, B, C, D, in which of these options the net force is actually zero? So let's analyze option by option. If we look at option A, this upward force can balance the downward force, but there is a third force which is going towards the right, which means the net resultant force is actually towards the right. So we can write for option A, the net force is not zero, which means option A cannot be the answer. Similarly, in option B, you can see that the upward arrow is smaller than the downward arrow, which means the net force in option B will be overall downwards. So let's write down even for option B, we can say net force is not equal to zero. Now, in option C as well as option C, net force is equal to zero. Let's see how. In option C, the up and the down arrow, they are of equal length, so they will cancel out. Also, the left and the right arrow, they are also of equal length. They also will cancel out. Similarly, in option D, the up and down arrow are of the equal length. So in C as well as D, net forces are zero. But which option do we actually select? That is where the catch is. A ball is thrown from an aircraft and the ball is outside the aircraft. So once the ball comes out of the aircraft, let me draw this diagram. So imagine we have a ball which is falling towards the ground with some velocity v. Let us analyze which all forces will act on the ball. One force will be W, which is the weight of the ball acting downwards. And now, remember the case of terminal velocity is only applicable when we are considering air resistance. So in this case, since the ball is falling downwards, we will say that the ball is experiencing an air resistance in the upward direction. Because try to recall the concept, direction of air resistance is always opposite to the velocity. So since velocity is down, air resistance will go up. Apart from these two forces, there is no other force acting on the ball. And that is why the answer is actually D, where the upward arrow is the air resistance and the downward arrow is the weight of the object. Now, there is one common error which a lot of students make. They think, what about the aircraft? The aircraft is going towards the left hand side. So even the ball should feel a force going towards the left hand side. So that is partially true. Why partially true? Let us analyze when the ball is inside the aircraft. So let me draw. Let's say we have a ball inside the aircraft. So now the aircraft is moving to the left hand side, which means definitely the ball is experiencing a force towards the left hand side. So this F, which I have drawn, this is the force acting on the ball because of the aircraft. Apart from this force, we have the weight W of the ball acting downwards. Now, the catch here is we are supposed to draw the free body diagram once the ball has exited the aeroplane. So, once the ball comes out, this F will no longer be applied on the ball. So, when the ball is outside, there are only two forces. One is the weight acting downwards, and then we have the air resistance, which have to balance out because remember, acceleration will be zero at terminal velocity. So, D is the answer.